to use the dot product theorem, what we need to find is first of all, what u dot v is. Then we need to find both the magnitude of u and the magnitude of v. For u dot v, we look at their horizontal components first. Negative 3 times 2 is negative 6. We then look at the vertical components. 1 and 5 is 5, which gives us negative 1 for our dot product. Okay, next we're going to find the magnitude of u. Remember, this is the distance. We use Pythagorean theorem, so we take negative 3 squared plus 1 squared, which is 9 plus 1. We take the square root of that number, so we get the square root of 10. For the magnitude of v, we're going to take 2 squared plus 5 squared, take the square root of that number, which gives us the square root of 4 plus 25, that's the square root of 29. Now we have these three numbers, we can figure out our dot product theorem. So we get cosine of theta is going to equal the dot product all over the magnitude of u times the magnitude of v. So we get negative 1 all over the square root of 290. Calculator magic. So we plug this in, we get negative 1 divided by the square root of 290 is negative 0.059 approximately. Now to solve for this angle theta, because we have cosine of theta equals negative 0.059. We need to use the cosine inverse or arc cosine. We take cosine inverse of negative 0.059. Use your calculator. My calculator is in radian mode. It depends, it's totally up to you which mode you want to be in, or which mode your instructor is going to be looking for. But in radian mode, I get 1.63 radians. Or, if I want to be in degree mode, I get approximately 93.38 degrees. I will accept either answer, as long as you include units and tell me that either theta is 1.63 radians or theta is 93.38 degrees. What this is telling us is that if we take the vector u, which goes negative 3, 1, so 1, 2, 3, and then 1, and we take vector v, which is 2, 5, so 1, 2, and then 1, 2, 3, 4, 5. The angle between these two vectors of u and v will be approximately 93.38 degrees or 1.63 radians. And that is the angle between our two vectors. Right, there's something nifty that happens, and yes, I use the word nifty, when we have two vectors that are perpendicular to one another. And if vectors are perpendicular, they're called orthogonal. These are two non-zero vectors such that what we see is that their dot product, when our vectors are orthogonal or perpendicular, is going to be 0. And the reason this is because if we're at a 90-degree angle, cosine of 90 degrees, or cosine of pi over 2 radians, is 0. So that means our dot product has to be 0. In other words, the angle theta formed by these two vectors is a right angle. But just so you make sure that you have these down, orthogonal vectors have a dot product that is equal to 0. So orthogonal or perpendicular vectors have a dot product that is equal